Hello friends, so today I'm solving this problem, strange printer. So there is a printer and basically this guy has two special properties of printing the characters. So the one special property is that this guy prints can print only the same sequence of same character at a time. For example, the printer can print a in an operation any number starting from 1 to any number. Okay, so in one operation it can print only the same characters. That is the one thing. And the second operation is that in it can start to printing the next set of characters from any index. So for example, we have just printed a, but that guy also can start printing from here. So it will cover the original a. So it might be happen like this. So this can be look like a, b, 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 because a, three a's are covered by this b, and this guy can go to any number of b, right? So starting from anywhere even can cover the already existing character. So these are the two properties. Okay, and with these two properties we are given one string s, and we have to find that what could be the minimum number of operations so that the printer can print that string. That is the what we have to do. So let's take one example. So for example, this string is given to us. So let's see how many operations it would have been taken. So for example, if this printer is printing first this set, okay, so one operation is here. He might be print this set again, then one operation is here, then one more operation for this. So how many operations? There are total 3 operations. But there could be another possibility that this guy is first printing all the A's like this. A, or initially he would have print all the a like this, and later point of time, at the later point of time in second operation. So here from till here how many operations? Only one operation. Now this guy can come with the b's like this, that he is starting the b's over here and overriding these existing a. So one operation is writing all the a, and another operation to write the overriding b. So how many operations? 1 plus 1. So this time it is 2 only. So to print this we have to find the minimum way. So 2 would be our answer. Okay, not this 3. So we have to solve these kind of scenarios. Now guys, we can observe one thing here, that all the same sequence which are coming together, okay, these are coming in one operation, right? For example, this 4a, they are contributing one operation, they are indicating one operation. So instead of taking all these frequencies, I can take them the single one from them, like a from this sequence and b from this sequence and another a from this sequence. So in this case my new string would be something like a b a. So why I'm doing in this way, I'm removing all the consecutive duplicates so that we are not consuming much of the extra space. Otherwise there could be like huge number of repeated same character. So I'm doing in this way, a, b, a. Now we can do our solution for this new string after removing all the consecutive duplicates. Remember, consecutive duplicates, not all the duplicates. So like this is the consecutive duplicates, then I'm taking one character. Similarly for all this. So now I can solve my solution for this a, b, a. Okay. So now we have to find all the operations, that how many operations it would have been taken for a, b, a. So let's think about our approach now. So as can you observe one thing here, like in this case also, for example, ABA is our string. So in this case we can split this string in many ways, right? Because split can happen at either at this location or at this location or at this location, anywhere, right? So we can split it like this, A and BA, right? Or we can split it like AB and A, right? Or we can split it like yeah, this is what we can do, right? So split is a distance, right? So if this is a three distance string, right? So we can have a split at 0 to length minus 1, right? 3 minus 1, so that we would be inside the string at starting from extreme positions. So in this case what will happen, we have observed one thing here, that whatever we have split, if the last character of this split first part and the end character of the second part of a split. If they are matching, this gives a indication to us that the in between characters are overwritten. Like in this way, we wrote the BB at later point of time. So this is giving us an indication that we can reduce at least one like this. Let's take an example. Let's say AB is our string. So it looks like it will take three operations, but actually we can do a in one operation, and later point of time we can do a because we can override this a, right? So we can make it a. So in two operations we can do. So if we have such kind of a string, and if we are finding, if we split it like this, that means the last character of it and the end character of second string, if they are matching, that means we can reduce one operation. Okay, so in this way we are looking for all the split, and we will look that is there some split set which having the end character of first part and last character of second part, or are they matching? If they are matching, then we can reduce operation by one because of this reason. Okay, so with this approach we will go for the dynamic programming solution for this. So let me explain it how it would work. So these would be our initial steps, right? So in step 1 we will remove all the consecutive duplicates. So like this, we will keep it like A, B, A. So we removed all the consecutive duplicates. That is our step 1. Then we will look for the solution for this modified string, the one which we got after removing. Now in step 3 we will split the modified string in all the possible ways, right? And there could be all the combinations, and we will look for the solution with all the help of all the combinations. Now we will use a dynamic programming DP. So we will create a DP array. Okay, the DP array would be basically a two-dimensional array which would be of like n and n length. Okay, so why n and n? So because we can have like starting from any point, starting from 0 to n minus 1, right? And similarly ending at 0 to n minus 1. So for that reason we have to create the array of n and n size. So our dynamic programming, this would be of size n and n, and then at any index dpij, basically it indicates that any substring which is starting at I and ending at j. Okay, so that substring I have given I and j starting and end. That substring, how many operations it would take to print that. So dpij would be the solution of a sub-solution of starting I and ending at j index substring, and we will use this property to get our final solution. Okay, so what that approach is basically, so and any string which has only length 1, okay, it will take always the one operation, right? So what we will do is we will write for all the ij which are I equal to j, right? So all the dp I and j, we would put it directly 1, right? So we can say that all the I equal to 0, because our length could go to from 0 to n minus 1, right? So for all I starting from 0 to n minus 1, we will put I basically. We can keep it I because we need only the same thing. So dpi equal to 1. So first of all, this would be our very first operation. Now for one length we are done. Now we are left for all the lengths which are starting from d equal to 2 to d equal to whatever length it has, right? Or whatever the string length it, right? So d equal to 2 to d equal to length. Okay, so whatever it has length, you can call it length or n, whatever it is, right? So this could be the remaining thing. We have to fill this dp array because we are already filled for the one length substring. Now we are left with substring of length starting from 2 to starting from entire length of the given string, right? So for this distance we have to find all the split, and then we will check that how we would proceed. So let me proceed for that as well. So see here, our n is 3, right? The length of this sorted string. So we will see all the diagonals, we will put 1, right? Because this is starting at 0, ending at 0. This is starting at 1, ending at 1. So wherever I equal to j, I am directly putting 1. Okay, now we have to start for distance equal to 2, 2 and distance equal to 3. we have to make all those split, right? There would be t2 and the distance, so right, less than n or equal to n, right? So now see here, so this would be our basically the approach to filling the TP. So at starting at any index and ending at any index for a given substring of the of this string, what we have to do, we will basically split it. So it would be equal to TP start plus split. Okay, because split is a length between 0 to D, right? Whatever length of substring is. So start and ending at start split plus dp starting from the next character. So start plus split plus 1 till end. Okay, so it would be something just like this. Let's say we have this thing a b a, right? For example, we are splitting at b, right? So this would be like a b, whatever operation we took to make the a b, plus whatever operation we took to the rest of it, plus a, right? Now this would be our basic formula, but there is one more condition, that whenever we are matching this guy start plus split character with the end character of the entire string, okay, in that case what will happen, whatever answer we are getting, we have to basically deduct it by 1 just for same operation. Let's say if let's say we have split it like this, a and ba, right? So a and ba, this would be our this character start plus split, right? And this would be our end character. Now initially we would have calculated 3, but because this split plus start and the end character are matching, then we will do 3 minus 1. Okay, so this thing we have to, this condition we have to take care, and rest of all will be as it is. So let's fill this this existing table. So see here, we are done for 1 length. Now we will look for the 2 length and 3 length. So initially what we are doing, anything which is taking the let's say starting at 0 and ending at 1. So what would be the length of it? Its initial length would be 2, right? So I am putting here 2. Why? Because we could have like, who know, there could be all the characters different, right? Let's say a, b, c, d. Then in worst case it could be equal to the whatever length of the substring. So see here, starting from 0 ending at 1, it would be length 2, so I am putting 2 here. And similarly, starting from 0 ending at 2, this would be of length 3, right? So I am putting 3 here. Similarly, come here, starting at 1 and 0, this would not be combination of anything which is starting at 1 and ending at 0 is not a possible thing. So we will keep it 0. Now starting at 1 and ending at 2, this would be of length 2, so we would put length 2 here. Now come here, this would be 0, this also would be 0, because we cannot have a string which is starting at 2 and ending at 1. And so here this is 2 and 2 which is already filled. Now we have to look for further thing, because anyway our solution should be here at last one. So let's fill it now, all these things, right things, right? So let's take an example which is starting at 0 and ending at 1. So this is a b, right? Starting at 0 and ending at 1. So this string is ab, substring is ab. Now how can we split it? We can split it like a and b, right? So in this case, how many operations would be there? We can split it. So one operation for this and one operation for this. And in split there is no possibility of ending matching, right? So we can keep it as it is 2. So let's make it 2 only, because nothing is changing. So all are different, so there is no possibility. Now come to another substring starting at 0 ending at 2. So what is that? Starting and that is ABA, right? So for ABA what will happen? We can have all the split it, right? So let's look for the split of it. It could be A, B and A, right? So this guy is the last one and this guy is the end of this string, right? End of this string is A. So this guy is not matching with this, right? This is not matching. So this combination is giving us 3 only, right? But we are looking for the minimum. So let's go to for another combination. we can have a split at A, and we can have a split at this guy, right? Split at here, right? So this would be A and BA, right? In this case, what is happening? This guy is first split and this guy is our end character, right? So these guys are matching here. So if they are matching, that means we have to deduct whatever original value we have. But what is the original value? It is 3. But because this guy and this guy is matching, we have to make it 3 minus 1. So what would be new value? New value would be 3 minus 1 equal to 2. Right? So we have to override this value 2 here. So this will be new value would be here 2. Okay. Anyway, we are done till here. Now we will go to another thing. So see here, let's go for the starting at 1 and ending at, see here, this is 1 and ending at 2. Okay, so this is the start point and this is the starting at, we are taking this guy, right, for this, starting at 1 and ending at 2. So this, we will take this guy, okay, at this location, starting at 1, ending at 2. So this is BA, right? So BA is the substring. Now how many split we can do? We can have a B and A. All are distinct character, right? So no matching. Okay, so nothing changed. We will keep it as it is, 2 only. Okay. Rest other are already done. These things are not possible. We cannot have a string which is starting at 1 and ending at 0. So keep them as it is. Let's say keep it at 0, 0. Now what we have to return out of this? We have to return the dp of 0 and n minus 1, right? Starting at 0 and ending at n minus 1, because this would be our entire string. Okay. So what is this value actually? This is dp of 0 and 3 minus 1. So dp of 0 and 2. So what is the value at 0 and 2? The value at 0 and 2 is here, right? This is 0. This is our 0 and this is 2. So what is the value here? This is 2 basically. So dp02 is equal to 2, which should be our answer as well. This is the answer which we have to return. So you can confirm with the string as well. This is our ABA compressed string, right? And we can write this string with 2 operations, which we already covered, right? We write first A and then override here B. So 2 operations are only required, which is the answer for this entire string, because we compressed this string only. So this is the dynamic way. Let me go to corresponding code of my this thing. So first of all, I have written one this remove consecutive duplicate method. So this is a simple method. Just I'm making one string builder here, and see here I'm first initially assigning the first character to it, and in this while loop I am checking that till the time the characters are repeating, let's increase the I, and then we are again coming it and appending it into SB. So basically finally we are returning the compressed string. So without no consecutive duplicate string would be returned, just same this string we got, right, ABA out of this string. So now after doing this, so this is our dynamic programming method. So first of all I have got the our compressed string after removing that, and then I'm getting the length of it, and this is our dp. Here I'm filling all the single one length substrings. I'm putting the value 1. Okay, then see here we are going now we are left with distance equal to 2 to n length, right? That is the possibility for our remaining substrings, right? So now what we are doing here, our start could be starting from 0 to start plus length minus 1, because we have to take care we can go only till less than n, right? We can starting from very first till the very last character and ending it. Now see here, end would be obviously start plus whatever distance minus 1. So we got the start and end. So see here we are looking for all the substring possibilities. Okay, so initially what I have done here is I have put here this dp start end equal to d, whatever distance is, because maximum we can, let's say we could have a b c d all the distinct character, right? So we would be having this would be our max length in the worst case, you can say, right, because all the characters are different. So I have put equal to whatever distance we are right now taking. Now we have to put the split. So to put the split, I am going from starting till 0 to d minus less than d minus, so up to d minus 2, because we have to take care of the indexes. So we are see here, we one operation I am taking this, that start and start plus split plus next part of it, because we have split, let's say we split at this point, then the starting from next point till the end. So this would be our minimum operation initially. Now see here, I am checking this guy, that the last of the first part character, is it matching with the end of the string, just the way which we were doing here, right? We did like this a, b and a, right? So we did this a and b a, right? So here this guy was matching with the last string, so that part I am putting there. So if they are matching, that means we can remove it by one operation, because we are doing basically with the override operation here. So we are just deducting it by one. And see here, I am putting the minimum operation out of whatever already value was there, and we will check whether if it is less, then we would be updating it. And finally, when we are coming out of this loop, we are returning our dp0 and n-1, because our string is basically substring which is starting at 0 and ending at n-1. So we are returning this. So let me execute this. It is working fine. Let me submit it. Yeah, so it is submitted basically. So it's a time complexity is n cube basically. You can check, we are using 3 loops, right? And space complexity would be n square, because we are using n into n space. Okay, so if you guys have any concern, please make a comment over there, and thank you for watching this video.